There is a potential safety benefit to having two separate neutral wires running back to the plug. If one neutral wire fails or becomes disconnected, the other neutral wire can still provide a path for current return, reducing the risk of voltage imbalance and potential overheating. However, this is not an explicit requirement of the National Electrical Code or generally considered necessary for typical home or commercial use. The configuration described is National Electrical Code compliant. The National Electrical Code allows for multiple neutral wires to be connected to a single terminal on a plug or panel board. Utilizing a 10/4 cord to the split would accomplish the same thing as using two 10/3 cords, and it would also meet the National Electrical Code. The 10/4 cord would provide a shared neutral for both sets of outlets. There are additional considerations to review. The neutral wires must be properly sized according to the ampacity and voltage of the circuit. All connections should be made using approved methods and materials. The Cordset should be protected from damage and used in accordance with the manufacturer's instructions. It is crucial to understand the reasons behind the use of two neutral wires instead of one in this type of Cordset. The primary reason for using two separate neutral wires, even when connected to the same neutral blade on the L14.30p plug, is to minimize the potential for voltage drop and to enhance safety. When two sets of receptacles share a single neutral wire, that wire must carry the combined current from both circuits. This higher current load can lead to increased voltage drop, especially over longer distances or with heavier loads. By using two separate neutral wires, the current load is distributed, reducing the voltage drop and improving the overall performance of the connected devices. Another critical aspect is safety. If one of the neutral wires becomes compromised, the other can still provide a return path for the current, preventing a dangerous open neutral condition. This redundancy enhances the safety of the setup, especially in situations where the Cordset is subjected to wear and tear. The National Electrical Code, or NEC, plays a significant role in ensuring the safety and compliance of electrical installations. The NEC provides guidelines for wiring and equipment, including the use of multiple neutral conductors. Although the NEC does not explicitly require two separate neutral wires in this specific configuration, it allows for it, provided that all conductors are properly sized and installed. This flexibility allows for designs that enhance safety and performance, even if not strictly mandated by the code. When considering the use of a 10/4 cord as an alternative, it's essential to understand its implications. A 10/4 cord contains 4 conductors, 2 hot wires, 1 neutral wire, and 1 ground wire, all within a single jacket. Using this type of cord could simplify the wiring at the split point, but it also means that both sets of receptacles would share a single neutral wire. While this configuration can be compliant with the NEC, it eliminates the redundancy provided by the two separate neutral wires. Therefore, the choice between using two 10/3 cords and a single 10/4 cord depends on the specific requirements and priorities of the installation. If redundancy and reduced voltage drop are critical, then the two 10/3 cord configuration is preferable. If simplicity and cost are the primary concerns, then the 10/4 cord might be a suitable alternative. When working with electrical systems, it is crucial to adhere to certain best practices to ensure safety and compliance. Firstly, always ensure that all conductors are properly sized for the intended load. This means selecting wires with an ampacity rating that is sufficient to handle the maximum current that will flow through them. Secondly, use only approved methods and materials for all connections. This includes using the correct types of connectors, ensuring that all connections are tight and secure, and protecting the wiring from damage. Thirdly, always follow the manufacturer's instructions for the use of the Cordset. This includes not exceeding the rated capacity of the Cordset, protecting it from physical damage, and using it in appropriate environmental conditions. In addition to these general best practices, there are also some specific considerations for this particular type of Cordset. Firstly, ensure that the L14.30p plug is properly connected to a suitable power source. This plug is designed for use with a 240 volts, 30 amp circuit, so it should only be connected to a properly rated receptacle. Secondly, Be mindful of the load distribution across the 4 5.15R receptacles. Each pair of receptacles is on a separate circuit, so it is essential to balance the load between them to avoid overloading any one circuit. Thirdly, regularly inspect the cord set for any signs of damage, such as cuts, abrasions, or loose connections. If any damage is found, the cord set should be repaired or replaced immediately. To further elaborate on the National Electrical Code compliance, it is important to understand some of the specific articles and sections that apply to this type of cord set. Article 400 of the NEC covers flexible cords and cables, and it provides requirements for their construction, capacity, and use. Section 400.5 specifies the allowable ampacities for flexible cords and cables, and it is essential to ensure that the conductors in the cord set are properly sized according to this section. Article 250 of the NEC covers grounding and bonding, and it provides requirements for ensuring that electrical systems are properly grounded to prevent electric shock hazards. Section 250.130 specifies the requirements for equipment grounding conductors, and it is essential to ensure that the grounding conductor in the cord set is properly connected to the equipment grounding system. Article 310 of the NEC covers conductors for general wiring, and it provides requirements for their insulation, ampacity, and installation. Section 310.15 specifies the allowable ampacities for conductors, and it is essential to ensure that the conductors in the cord set are properly sized according to this section. In addition to these specific articles and sections, there are also some general requirements in the NEC that apply to all electrical installations. These include requirements for workmanship, accessibility, and protection from physical damage. It is essential to be familiar with these general requirements and to ensure that all electrical work is performed in accordance with them. To provide some more practical advice, let's consider some common scenarios that might arise when using this type of cord set. Firstly, what should you do if one of the receptacles stops working? The first step is to check the circuit breaker or fuse that supplies the circuit. If the breaker has tripped or the fuse has blown, reset the breaker or replace the fuse. If the receptacle still does not work, check the wiring connections at the receptacle and at the plug. If any of the connections are loose or damaged, repair or replace them. Secondly, what should you do if the cord set becomes damaged? If the damage is minor, such as a small cut in the outer jacket, it may be possible to repair the cord set by wrapping the damaged area with electrical tape. However, if the damage is more severe, such as a broken conductor or a damaged plug, the cord set should be replaced. Thirdly, what should you do if you need to extend the length of the cord set? It is generally not recommended to extend the length of a cord set by connecting it to another cord set. This can create a safety hazard by overloading the circuit or by creating a tripping hazard. If you need to extend the length of the cord set, it is better to use a single, longer cord set that is properly sized for the intended load. When dealing with electrical systems, it is always best to err on the side of caution. If you are not comfortable working with electricity, it is best to consult with a qualified electrician. An electrician can help you to ensure that your electrical system is safe and compliant with the National Electrical Code. In summary, the configuration of the Extenda Panel cord set with L14.30p to 4x 5.15R setup involves careful consideration of neutral wire configurations and NEC compliance. The use of dual neutral wires offers a potential safety benefit by providing redundancy and reducing voltage drop. While NEC allows for multiple neutral wires connected to a single terminal, it doesn't explicitly mandate it for typical use. Utilizing a 10/4 cord as an alternative is possible, but it eliminates the redundancy of separate neutral wires. When working with electrical systems, always prioritize safety by adhering to best practices such as proper conductor sizing, approved connection methods, and following manufacturer's instructions. Regular inspections for damage and avoiding overloading circuits are crucial for maintaining a safe electrical setup. Understanding relevant NEC articles and sections, such as those covering flexible cords, grounding, and conductors, is essential for ensuring compliance. Practical advice includes troubleshooting receptacle issues, addressing cord set damage, and avoiding unsafe extension practices. When in doubt, consulting a qualified electrician is always the best course of action. Remember, electrical safety should always be the top priority. The principles discussed here are applicable to a wide range of electrical applications beyond just this specific Cordset configuration. Understanding the importance of proper grounding, conductor sizing, and NEC compliance is crucial for anyone working with electrical systems. Whether you are a homeowner, a contractor, or an electrician, a solid understanding of these concepts will help you to ensure the safety and reliability of your electrical installations. The concept of voltage drop is a key consideration in electrical design. Voltage drop occurs when the voltage at the load is less than the voltage at the source. This can be caused by the resistance of the conductors, the length of the conductors, and the amount of current flowing through the conductors. Excessive voltage drop can cause equipment to malfunction, reduce the efficiency of electrical systems, and even create a fire hazard. To minimize voltage drop, it is important to use properly sized conductors, minimize the length of the conductors, and reduce the amount of current flowing through the conductors. The National Electrical Code provides guidelines for voltage drop in branch circuits and feeders. The NEC recommends that the voltage drop in a branch circuit should not exceed 3%, and the voltage drop in a feeder should not exceed 5%. These recommendations are based on the need to ensure that electrical equipment operates properly and efficiently. Grounding and bonding are essential for electrical safety. Grounding is the process of connecting electrical equipment to the earth, while bonding is the process of connecting different metal parts of an electrical system together. Grounding and bonding help to prevent electric shock hazards by providing a low impedance path for fault current to flow back to the source. When a fault occurs, the fault current will flow through the grounding or bonding conductor, causing the circuit breaker to trip or the fuse to blow. This will de-energize the circuits and prevent a dangerous shock hazard. The National Electrical Code provides detailed requirements for grounding and bonding. These requirements are based on the need to ensure that electrical systems are properly grounded and bonded to prevent electric shock hazards. Overcurrent protection is another essential aspect of electrical safety. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. When an overload or short circuit occurs, the overcurrent protection device will trip or blow, interrupting the flow of current and preventing damage to the electrical system. The National Electrical Code provides detailed requirements for overcurrent protection. These requirements are based on the need to ensure that electrical circuits are properly protected from overloads and short circuits. In addition to these specific safety considerations, it is also important to be aware of the general hazards associated with electricity. Electricity can be dangerous if it is not handled properly. It is important to follow all safety precautions when working with electricity, such as wearing appropriate personal protective equipment, using insulated tools, and de-energizing circuits before working on them. If you are not comfortable working with electricity, it is best to consult with a qualified electrician. An electrician can help you to ensure that your electrical system is safe and compliant with the National Electrical Code. The information provided here is intended for educational purposes only and should not be considered a substitute for professional advice. Always consult with a qualified electrician before working on any electrical system.